All right, y'all, this is number 8 on Unit 1 concept list. We're going to talk about derivatives. If on your test I say find the derivative or the rate of change formula, and I do not emphasize that you must use the limit notation definition of a derivative, then I want you to use the shortcuts from Chapter 4. So that's what we're going to practice here on these examples, is using our shortcuts by breaking our function that we see into the different pieces in the expression itself. So this first one, we've got 1, 2, 3, 4 pieces, and what we're going to do before we apply our rules is see if we can rewrite this in any way to make our life easier. So this first piece already looks good. I'm just rewriting that. But what's going to make our life easier with square roots is changing that to our 1/2 power. So I'm going to rewrite it -6, and then x gets raised to the 1/2 power. Same thing with fractions. We're going to rewrite it as negative exponents so we can apply the same power rule. And that last piece, no problems, just bring it along for the ride. Now we can go ahead and find our derivative using power rules on just about all of these. So first one, we're taking our power and multiplying it. 3 times 12 is 36. Our power is reduced by 1, so then we've got 2 for our power for that piece. Second part, same concept. We're taking 1/2 times 6, so that's a negative coming down 3. And when we decrease our power of 1/2, we get a negative 1/2. Okay, next piece, negative comes here, so that's a negative 3x. Decreasing that power is negative 2. And then here's the one that's not the power rule. When we have e to the x, what we need to do is remember that the derivative of e to the x is itself as long as x is the only thing in the exponent. Okay, watch out, you will have to use chain rule on some of these problems. Okay, but in this case, it's just coming down e to the x. Then we're going to just do some reformatting with our negative exponents so they look a little bit nicer. So first piece just comes down 36x squared, but this negative exponent does two things. We're going to move it to the bottom, but I'm also going to fix it back to the original notation. Remember that 1/2 came from using our knowledge about square roots, so we're going to go ahead and flip it back at this stage. This part, we're just moving that x squared to the bottom to get rid of the negative, and then this plus e to the x comes down, and we are all done. Next piece, same process. We want to rewrite it to make it nicer if possible. This first part we want to make nicer. Here's how. When we see an x on top, it's really the same thing as thinking about this coefficient in front. When we don't see a number, it's really 1. So this can be rewritten as 1/4 x, and that's going to make our life easier as we go to simplify here. It looks like the rest of our equation here is just fine, so I'm just going to bring it down, and then we'll go apply our derivative rules. Okay, so first part, when we're finding the derivative of this part, when we just have x to the first power, the 1 still comes to the front, but then when we decrease this by 1, it becomes x to the 0 power. Anything to the 0 power is 1, so the x portion goes away. Okay, so we're just going to have a constant left over. Okay, so that's our 1/4. Sorry, that looked a little bit weird. Second part is just a constant, so that goes away. It's just 0. Next part, 3/5, we're going to multiply to the front, so that's negative 21. And the 3.5 decreases by 1 to 2.5. And here's what I was talking about with the chain rule. The derivative of e to the 2x is going to be e to the 2x times the derivative of the exponent 2x. So the derivative of 2x is 2, that coefficient like we were talking about with this. And then the only thing that we would do to make this derivative function a little bit nicer is maybe put this 2 in the front. And a lot of times I'll actually put the constant on the end as well, but it's not required. Okay, so I'm just bringing the rest down and smushing that 2 in front of the e2x. And that's it. Okay, next part, what's really important here, there is no plus or minus between here, okay, but there also is no times, but it means times there. This is a product. Okay, and it's really hard to see unless you're training your brain to know that natural log is a separate function. So we've got 2 separate pieces here. Okay, so what we're needing to do here is use the product rule. So we have to think about our 2 pieces And you can call them f and g or u and v. They're different forms of this. It does not matter to me. But here's what does matter. You're going to take the derivative of the first part. I like to start with that. It technically doesn't matter. But we're going to do the derivative of this first part. So that would be 2x using our power rule times, leave the second part alone. And then you just switch. So when you do your plus, we're going to switch and now take the derivative of the second one. And the natural log derivative, we got to remember, when we're talking about the derivative of the natural log of x, it's 1 over whatever is here times the derivative of the inside if we have a chain rule situation. So here, the derivative of natural log of x is just 1 over x, and it's times the other part, the x squared. So then when we simplify, this first part we really can't do much with other than smush them if you want to. And then the second part, when we rewrite it, is x squared. I'm going to go ahead and add an extra step here. X squared over x. And then using our quotient rule with powers, we've got more x's on top, so it's 2x natural log of x plus x. And you can see this is a different order than what they gave you, but again, like I said, you can switch those around. It doesn't matter which one you do first because addition is commutative. I like to do the derivative of the first part always because that's how it looks in the quotient rule. So it's a little bit of consistency there to help you remember them. Okay, so next part, we've got a natural log, and this is what I was talking about, is sometimes you have extra pieces in your natural log, and so that's telling your brain that chain rule has to happen. So we're still going to use our rule where it's 1 over the inside stuff here. So this x squared minus 7x, that's the first part, just the derivative of the natural log is 1 over the thing inside the parentheses. But then we have to multiply it by the thing inside the parentheses derivative. Okay, so we're going to do the derivative of each piece here. X squared is 2x, and minus 7x is minus 7. And then kind of like last time, we're going to rewrite, okay, this is really on top, so straight across 2x minus 7. And on the bottom, x squared minus 7x. Because there are two terms here, okay, being added and subtracted, you can't cancel up and down because of the order of operations telling you to do this before you divide. Okay, so when you see that plus or minus, you can't simplify, you leave it alone from there. Alright, now we're going to talk about that quotient rule that I mentioned. Okay, so again, I like to do this in a little bit different order than the rule, but it helps my memory. Okay, so we've got two pieces here, the first one and the second, and I'm always going to start with the derivative of the first one. Okay, that's for the product rule, that's for the quotient rule. So derivative of the first one, okay, 2 to the x is just 2 to the x, but one other thing, when you've got this base, okay, when you're looking at an exponential function, we also have to multiply by the natural log of that base. Okay, I want to talk about this in terms of exponentials with base e, because this rule actually applies for them as well, we just don't think about it. Okay, so we know that the derivative of e to the x is e to the x, but here's why. Okay, it's the derivative using what it is times the natural log of the base. Well, the natural log of e is 1, and that's why we've been skipping that portion. Okay, this is true for all exponentials, including base e. There's just a shortcut when it is e. Okay, going back here, so we've done the derivative of the first, now we're multiplying it by the second. Okay, so that's my x cubed. And then we're subtracting, flipping them. Okay, so I've done the derivative of this, now I'm going to change to the derivative of this. So this would be 3x squared times the original 2 to the x. Okay, so the order of these items have flipped, but not the whole terms. That's important. You cannot change the order of the subtraction because subtraction is not commutative. Okay, so that's important. Last thing, then you're going to just take this bottom part and square it every time. Okay, so that's what we're starting with, and we're just simplifying if we can. Okay, so here's what I want you to do first when you're trying to simplify, because a lot of times with your quotient rule, there's going to be some factoring in the top that ends up happening. So what I want you to do is really emphasize to your brain that this first piece is one term and the second piece is one term. It's split up by the minus. If you can ever rewrite the order of the items in those terms so that the things you see in common are written in the same order, that is going to help. So here's what I mean by that. I see this 2 to the x in both. I'm going to start by rewriting and making sure that 2x comes first. Okay? There's also an x term that shows up in both, so I'm going to write this x cubed next and then the natural log last. Over here, I'm going to put it in the same order. The 2 to the x I'm going to put first, and then this times the 3x squared I'm going to put next. Okay, and then on this here power rule, it's x to the 6th power. Now why I did that is because now we can really clearly see that a 2x is showing up in both, and also an x to some power is showing up in both, and that's what we're going to factor out next. So 2 to the x we're going to write, and with this we want to write just the smallest power, so only x squared can come out, and then we can rewrite through here. Okay, so here's how this works. When we've got our x squared, we have 1x left over, so we got to write it, and then we have to write that natural log of 2 because I didn't do anything with it. This second part, minus. This part, when I factor it out, is just leaving 1, okay? And if you want to write that, you can. This second part is just the times 3 because the x squared is coming out, and then I'm dividing by x to the 6th. Okay, I'm going to make this inside look a little bit nicer. So 2 to the x stays, x squared stays, inside. This part, doesn't matter which order I write them, I'm going to keep it, but I'm going to just call that 3 at this point. Okay, but at this point, we're going to go ahead and take care of that denominator because these pieces can simplify. I've got more x's on the bottom. There are 4 more on the bottom, so I'm going to rewrite it like that. The 2x stays. This x natural log 2 minus 3 stays, but this becomes x to the 4th, and now you've got the same thing as up here. Okay, the process took some extra steps, but those extra steps help you make sure you don't miss anything while you're factoring those like terms. Alright, last one here is with this square root. Again, rewrite it so it looks nice to help you before you apply your shortcut rules. We're keeping the 3x squared plus 8x, but we're putting in the parentheses to the 1/2 power. That's going to help us. Okay, we're using our power rule. So our derivative is 1/2, keep those parentheses, 3x squared plus 8x. Reducing this by 1 is a negative 1/2, but because there was more than just x there, we have to also multiply by the derivative of the inside using the chain rule. So 2 times 3 is 6x to the power of 1, and then plus this 8x derivative is just 8. Okay, so now we're going to do some rewriting here. Remember, negative exponents, just move it to the bottom. So when we're looking at this, we've got 1 over, this 2 stays on the bottom, but so does this part. Okay, so 3x squared plus 8x. And then again, this is to the 1/2 power. We're going to change that back to a square root. This part, 6x plus 8, is really on the top. Okay, so we can rewrite it in our final step, 6x plus 8. Okay, over here, we've got our 2, and then square root of 3x squared plus 8x. And I would actually do one more thing, and they didn't do that, but I can see it's happening here. This is a 6, this is an 8, this is a 2. You can actually factor out a 2, call that 3x plus 4 on the bottom, 2 times that square root 3x squared plus 8x, and then those cancel, and that's just a little bit nicer than that version. Okay, honestly, for this test, I'm going to award way more points for this portion than the simplifying portion. I'm way more interested in knowing that you understand the derivative rules from Chapter 4, And then I'm less worried about how well you can simplify it, except for when it applies to those application problems. Okay, so just make sure you really understand your product rule, power rule, quotient rule, and chain rule. Okay, then of course you got to know your special e to the x derivative and natural log of x derivatives as you go through here and review those problems.